Hello everyone. Already we have started discussion about metallurgy topic. Okay, so in that metallurgy we were discussing about what in the previous class about the concentration methods. In that froth flotation process we are discussing, which is very important method of concentration method. Okay, so in this class we are going to discuss about what now we are continuing with the froth flotation process. In this froth flotation process, sometimes we use activators and depressants. Okay, so when we add some oil to the suspension of the ore powder is mixed with water. Through that slurry, slurry, slurry means burada. Through that slurry, through that suspension of ore powder in water, we pass what some air under high pressure. Okay, when you pass air through this suspension with oil, when we add oil to the ore powder in water, what happens there? The froth will be forming. Froth means what? Foam. Along with the froth bubbles, what will come out? The ore particles will attach to froth bubbles, and the froth will be coming to surface of the suspension. Okay, and from there the froth will be separated and ore particles are separated. At the bottom, impurities will be left over. We know at the bottom of the froth flotation cell, the impurities are left over, gong particles are left over, and to the surface, what will come? The ore particles will be coming to the surface along with the froth. Froth means foam. Okay, so here sometimes here activators will be added. What will be added, ma? Activators are added. So these activators, the activators will be making the particles attached to froth bubbles. That means the activators will activate the particles to attach to what? The froth bubbles to come to surface. And depressants there now. Another compounds what now here? Depressants. These depressants, depressants will be making the particles to be settled at the bottom. To make the particles settle at the bottom, depressants are used. If you don't want any particle to come to surface, if you want the particles to settle, if you want the particles to be settled at the bottom, we add what? Depressants. The depressants will make the particles settle at the bottom. Activators will activate the particles to come to surface along with the froth. That point mainly keep in mind. So it's about what now here? The activators and this one. So now here, already we discussed about this. Suppose if you take what now? PBS. If you take what now here? PBS, ZNS, FeS2. So lead sulfide, zinc sulfide, iron sulfide. These three are present in some mixture. Suppose in the mixture we have PBS, ZNS, FeS2. In this major quantity is what? PBS. Suppose PBS is ore. In this PBS ore, the impurities present what? Zinc sulfide, FeS2 as impurities. Now, what should come to the surface along with the froth? PBS should come. PBS will be coming to the surface along with the froth, and the froth will be separated, and hence PBS will be separated. Lead sulfide will be separated. And at the bottom, what will be left over now? ZNS and FeS2 will be left over at the bottom. To make ZNS and FeS2 settle at the bottom, we have to add what? Depressants. What will be added now? Depressant will be added. Depressant will depress the ZNS and FeS2 to be settled at the bottom. And what will come to the surface now along with the froth bubbles? The PBS will come to the surface and PBS will be separated. Okay, after that at the bottom, which two are left over here? ZNS left over and FeS2 left over. ZNS and FeS2 both are left over at the bottom, suppose. Now what we have to do is that we add some activator now. We add some activator to the mixture of ZNS and FeS2 at the bottom. Now the activator will activate ZNS to come to surface. It will activate the ZNS particles to come to surface now. First to PBS separated. After that at the bottom, what are left over? ZNS left over, FeS2 left over. Now again, to separate the ZNS and FeS2 mixture, we add some activator for ZNS. That activator will make ZNS particles or particles to attach to what? Froth bubbles. Now along with the froth, what will come to the surface? ZNS will come to the surface, and hence ZNS will be separated. Now at the bottom, what will be left over now? FeS2 will be left over. FeS2 left over. Now again the FeS2 will be added with some acid activated. Another activated acid will be added to FeS2. Then what happens now, along with the froth again, FeS2 will also come to the surface and will be separated. So in this way, among the three here, PBS, ZNS and FeS2, what will be separated first one? PBS. After that, ZNS. After that, FeS2. Okay. So now they ask you most of the questions. They ask you between PBS and ZNS in the beginning, which will come to surface and which will settle at the bottom. Which will come to the surface? PBS will come to surface because it is wetted by oil. PBS is wetted by oil. That means the PBS particles will be attached to oil. They attract oil. That's why along with the oil bubbles, froth bubbles, the PBS will come to surface. Then secondly, what will be separated? ZNS will be separated by adding what? Activator. And lastly, what is separated from this solution? We get lastly FeS2. Okay. So this point we are going to discuss. What are activators and what are depressants? Now generally what will be collector here? Here. Now here potassium ethyl xanthate. Potassium ethyl xanthate is passed by passing potassium ethyl xanthate, which acts as what here? Collector. What is here? Potassium ethyl xanthate is used as collector. So along with what now it is added along with what now? Sodium cyanide. Sodium cyanide. NaCN. NaCN. Sodium cyanide. And what? Alkali. Alkali means soluble base. NaOH. Suppose NaOH is soluble base, which is called alkali. So ethyl xanthate, potassium ethyl xanthate, sodium cyanide, and NaOH alkali will be added. Now in this here, potassium ethyl xanthate will act as what? Collector. This will collect the ore particles to the surface. This will collect what? Ore particles and bring to the surface. And sodium cyanide and alkali, these two will act as what? Depressants. They will depress ZNS at the bottom. They will depress the ZNS particles to go to bottom and settle. So where by the flotation property of ZNS and FeS2 is depressed here. So where by the flotation property, what will happen now? Only PBS will be collected to the surface. And what will be depressed to the bottom? What will be depressed to be settled at the bottom? ZNS and FeS2 will be settled at the bottom. ZNS is nothing but zinc blend. What is the name of ZNS? Zinc blend. So zinc blend, ZNS will be settled at the bottom. FeS2 also will be settled. Next, mainly PBS passes into froth, into the froth bubbles. What will pass now? PBS. When air flow is when air current is flown in, when air current is flown inside, what happens now? The PBS will pass into froth, which is collected. The PBS is collected to the surface, or PBS is collected at the surface with the help of what? The collector called potassium ethyl xanthate. After PBS is removed with the froth, what will be left over now? ZNS left over at the bottom and FeS2 will be left over. So after PBS is removed, some amount, not same, some amount of copper sulfate activator is added. What will be added, ma? Some quantity of copper sulfate activator is added, and air is again blown. When air is blown again, froth will form. The froth will bring ZNS to the surface now. Okay. Now the flotation property, by the flotation properties of ZNS, what happens now? ZNS is increased, which is now removed. Means the flotation property of ZNS is increased now. By adding activator, the flotation property of ZNS is increased. The flotation property of ZNS is increased by adding what? Activator copper sulfate. Okay. Again, what now? The ZNS will pass into froth, and froth will come to surface and will be removed here. Next, the slurry. Slurry means what? Burada in Telugu. Slurry. So the slurry, how it is formed here? We added what now? Ore powder to the water. Potassium ethyl xanthate to the water. Some pine oil we added, and also sodium cyanide is added. Some alkali is added. It's all present in water, na? That is forming what? Slurry. The slurry is acidified, means added with some water. The slurry is added with some water, and the process is repeated again. Again, we have to pass air under high pressure. Again, froth will be forming. When FeS2 passed into froth, lastly, what will happen now? FeS2 also will pass into froth and is collected at the surface. And collected at what? Surface. So like this, what now here? First PBS is removed, then ZNS is removed, then FeS2 removed here. How PBS is collected at the bottom, at the surface? PBS is collected at the surface by what? Adding potassium ethyl xanthate collector. Sometimes pine oil will be used. Pine, P-I-N-E, pine oil will be used here. Next, what is used to? What is used to depress ZNS and FeS2 at the bottom? We use what? Sodium cyanide and alkali NaOH. These are used to depress at the bottom. They are called depressants. What are they called? The sodium cyanide is called what? Depressant. What is this called? Depressant. So depressant meaning what, ma? The substance which is added in froth flotation to depress any one particles to the bottom, to depress the particles to be settled at the bottom. That is depressant. So this NaCN is the depressant for ZNS and FeS2. NaCN is depressant for NaCN and ZNS2. That point we have to know. Okay. And next one. And which activator is added to collect ZNS? Copper sulfate activator is added to ZNS to activate the ZNS and go into the froth. In that case, the ZNS is collected at the surface. Okay. Next now. Electromagnetic separation. What is this one? Electromagnetic separation or magnetic separation, simply. Magnetic separation. Here, what we use here? Electromagnets will be used. Electromagnets are used. Electromagnets meaning what? As long as the electricity is passed, it will behave like powerful magnet. Whenever you switch off the electricity, immediately it becomes normal iron rod. Suppose iron ball is the iron wheel is suppose that iron wheel becomes what? Powerful magnet by passing electricity. When you switch off the electricity, it becomes normal iron wheel. That is called what now? Electromagnet. So this electromagnetic separation or simply magnetic separation. Okay, it is another important area. Okay, so froth flotation process of concentration is important and electromagnetic separation is important. So if the mineral and not the gong is attracted by a magnet. So if the mineral is attracted by magnet and not the gong is attracted by magnet, meaning what? Mineral is attracted by magnet. Gong is not attracted. So this mineral means ore. Ore is what now? Magnetic in nature. Ore is what now? Magnetic particle. And gong is what now? Impurity. Gong is what now? Non-magnetic. Gong is non-magnetic. So gong is non-magnetic, whereas ore particles are magnetic. Okay, in this condition, it can be concentrated. The type of impure ore can be concentrated by magnetic separation. For example, chromite ore. Example what here? Chromite ore. That is FeCr2O4. FeCr2O4 is called what? Chromite ore. So this chromite ore being magnetic. This ore particle is what now? This ore is what? Magnetic. This chromite ore particles are what? Magnetic. So they can be separated from non-magnetic silica impurities. Silica type. Silicones impurities are we say silica. So what we say here? Silica. Silica is what now? SiO2. Silica is what? SiO2. The silica impurity will be added here. Silica impurity will be present here. The silica impurity is non-magnetic, whereas the ore particles are what? Chromite ore particles are what? Magnetic in nature. They can be separated from each other by this electromagnetic separation. So remember this example, remember. Chromite ore contains what? Non-magnetic silica impurities. Okay. And FeCr2O4 is the formula of chromite ore. Okay, next. Sometimes two minerals occur together. Okay, two minerals will be occurring together. Means what now here? One ore particle and another ore particle. Both ore particles only. two types of minerals, two types of ore particles when they occur together. Okay, in which one happens to be magnetic. One ore particles will be magnetic. The other ore particles will be non-magnetic. So by magnetic separation method, the non-magnetic minerals, the non-magnetic ore is separated from what? The magnetic mineral. Okay. For example, tin stone. Tin stone formula what? SnO2. Tin stone is also called what? Cassiterite. What is the name? Cassiterite. Cassiterite or tin stone, both same. Cassiterite or tin stone, okay, will contain what now here? SnO2, non-magnetic. The ore particle is what? Non-magnetic. Ore particles are non-magnetic in this case. And they contain what now? Wolfram. Wolfram, FeWO4. Do you know what is W? W is what? Tungsten. W is what? Tungsten. Okay, wolfram, Latin name. Okay, FeWO4 is wolfram. So this wolfram is magnetic impurity. The impurity is magnetic now, remember. Sorry, FeWO4 is ore of what now? Iron. Ore of iron. And SnO2 is what? Ore of tin. The oxide ore of tin and oxide ore of iron. Okay, so these two will be separated from each other. Why they are able to be separated from each other? Because SnO2 is non-magnetic ore and another ore is what? Magnetic. So one ore, two. Second ore is magnetic one. First ore is what? Non-magnetic. First ore is non-magnetic. Second ore is magnetic. That's why they can be easily separated by this electromagnetic separation method. And in this method, in the electromagnetic separation method, a thin layer of finely ground ore. Ground means what? Powdered. Ground meaning what? After grinding the ore is called the ground ore. So a thin layer of finely ground ore is spread over a rubber belt. One conveyor belt we say. What we say? Rubber belt meaning what here? Conveyor belt. So on the conveyor belt, what is put here? The finely ground powder is put on the conveyor belt. Okay, so once you see this diagram, this diagram is there now. So it is called conveyor belt. What is called conveyor belt? So this moving belt is there now. So this is called what now here? Belt. Conveyor belt is taken. So on this belt, what we are putting this powdered, finely powdered ore. So finely ground ore. Finely ground means powdered. Finely ground ore is putting on is put on what here now? This belt. It is belt here. So on this conveyor belt we put it. So this will be moving in this direction here. It is magnetic wheel. This front wheel is what? Magnetic wheel. So now it is magnetic wheel, and when this ore particle, when the ore particles are coming vertically like this, it is vertically. So the particles are moving down vertically on the belt like this. When the ore particles are coming down vertically down, in this case, what happens now? The ore particles and magnetic impurity, means impurities and ore particles suppose there. The magnetic particles will be separated. Okay, magnetic particles will be separated here. The magnetic particles here. Magnetic particles will be separated below the wheel. And non-magnetic gong. Non-magnetic gong will be thrown away. Non-magnetic gong will be thrown away, and magnetic ore particles will be collected below the wheel, below the magnetic wheel. So this type of separation is called electromagnetic separation. Electromagnetic separation we say. Okay. So now what is given here? See, in this method means what? In this electromagnetic separation method, okay, a thin layer of finely ground powder ore. A finely powdered ore is spread over. It is spread over a rubber belt, moving belt, carried over a pulley in a magnetic field. That will be carried over a pulley in magnetic field. And the gong particles means impurity particles. Otherwise, the particles of non-magnetic material or mineral fall off. Fall off means they will fall away from. Okay, as the belt moves, becomes what? Vertical. When the belt is moving vertical, now initially belt is moving horizontally. When belt moves vertical like this, then what happens now here? Ore particles will be separated from gong particles. That means what? magnetic particles will be separated from non-magnetic particles. And what happens now? And the magnetic particles are collected. Okay, and magnetic particles collected the wheel, means below the wheel, below the magnetic wheel, below the magnetic wheel. So below the magnetic wheel, what will be collected here? This ore magnetic particles will be collected. Non-magnetic particles will be thrown away. The non-magnetic particles will be thrown away from the magnetic wheel. This is called magnetic separation. And next one is what now? Chemical methods. Chemical methods of what here? Concentration of ore. So in this first one is calcination. Calcination means heating in absence of air. So in this process, the concentrated ore means already the ore is concentrated. Means from the ore we have removed what? Gong particles. We removed the impurity particles. Then it is called concentrated ore. So in this process, in the calcination process, the concentrated ore is heated. The concentrated ore is heated in a suitable furnace. In a suitable furnace, the concentrated ore is what? Heated. Generally in reverberatory furnace. Which type of furnace is used here? Reverberatory furnace. Furnace means what? The device used to heat the ore at high temperature. Okay. So what here? The calcination process occurs in which furnace, ma? Reverberatory furnace. Okay. And it is carried out below its melting point in absence of air. So for one thing, what we have to remember is heating the ore in absence of air is called calcination. Heating the ore in absence of air is called what, ma? Calcination. Next, in calcination process, we heat the ore below the melting point of ore. In calcination process, the ore is heated below its melting point. That point we have to remember. And calcination process takes place in which furnace? Reverberatory furnace. So these are important bits. As a result of which the ore dries up. The ore will be dried up. When you heat, what happens, ma? The moisture will be evaporated, na? When moisture is evaporated, the ore becomes what? Dry. And moisture and volatile impurities are driven off, means removed. Driven off means for removed. What will be removed during calcination? Moisture is removed and also volatile impurities. The impurities which can be evaporated easily on heating can be removed here. And the carbonates are converted into oxides. This point is important. During calcination, carbonate ore will be converted into oxide ore. And the ore becomes porous. Ore becomes porous, meaning what? Small holes will be created. Means if you take this much lump of ore, LUMP lump of ore, the big piece of big rocky material of ore, if you take and heat, on heating, on calcination, what happens now? It becomes porous. Porous means what? The holes will be formed on the surface. Okay. So for example, what now here for calcination process? Yes, see. First, mainly you take carbonate ores like this. These two examples take first here. So zinc carbonate on heating, on calcination, we get zinc oxide and CO2 gas. CO2 gas is eliminated. So oxide ore is obtained from carbonate ore. Here also from calcium carbonate ore, we are getting calcium oxide ore. So on heating calcium carbonate strongly, calcium carbonate decomposes to calcium oxide and CO2. So this way we have to understand what? The carbonate ore is converted into oxide ore. Here also you see CuCO3 dot CuOH taken twice. Means copper carbonate and copper hydroxide. When heated, this carbonate ore, the copper carbonate will become what? Copper oxide. So this is what now here calcination process. And sometimes it is used for what? Aluminum oxide 2H2O and iron oxide 3H2O. 2 moles of Fe2O3 3H2O, 1 mole of Al2O3 2H2O will be heated to get oxide ore. Only oxide ore will be. It is hydrated oxide. Hydrated oxide. It is also hydrated oxide. Hydrated oxide ore of iron, hydrated oxide ore of aluminum. These two, when undergoing when they are subjected to calcination, okay, what happens now? Oxide ore will be formed. Iron oxide and aluminum oxide will be obtained here by the removal of what? Moisture, by the removal of water. So this is calcination process. Okay, ma'am. Next, roasting. Roasting means what? Heating in presence of air. So the process of heating, the ores strongly in presence of air. This is to be remembered, in presence of air heating, with or without certain substances. Okay, below its melting point. Again, we heat what below the melting point only. In calcination process also, we heat the ore below its melting point. Here also we heat ore below its melting point. But here in roasting we use oxygen. In calcination we don't use oxygen or air. This is termed as what roasting process. So it differs from calcination in the respect that heating the ore is done in presence of air in what roasting, and at higher temperatures. It will be heated. Next, in this process, in roasting process, the impurities of sulfur and arsenic are volatilized. Volatilized means what here? Volatilized means what now? They will be evaporated. Which impurities here? Impurities of the sulfur and impurities of arsenic are volatile in nature. They will undergo volatilization. Okay. Whereas as oxides, they will be giving what oxides here, and the ore is converted into oxide. The ore will be converted into oxide. Okay, and what now here? It becomes what now here? Sulfide ore becomes oxide ore. Remember here. So remember that the sulfide ore will be converted into oxide ore in roasting process. For example, zinc oxide is formed. Zinc oxide is produced by the oxidation of zinc blende. Zinc blende means what? ZNS. Zinc blende is what? ZNS. Like this, ZNS zinc blende and heated in air. This oxygen is from air. Heating in air is called what? Roasting process. So the zinc sulfide is roasted in air to get what? Zinc oxide and sulfur dioxide gas. So zinc oxide is produced here. So sulfide ore is converted into oxide ore in roasting process. So these are all things you have to understand, and the remaining chemical methods we will discuss in the next class. Okay, ma'am. Bye. Good day.